So here are my puppies, and here are my juveniles, and here are my adults. So my puppies grow up to become juveniles. Well, how many of them grow up to become juveniles? 60% of whatever I started with. My juveniles grow up to become adults, and we said 80% will make it into that adult category. Some of my adults are going to die off, but 70% of them are kind of going to feed back into the number of adults I have. To get new puppies, my juveniles are going to have babies, and they're not as good parents, so they're each going to contribute 2 new puppies. My adults, they're better parents, so they're going to contribute 6 new puppies. So if I started off with 20, 10, and 15, then after we go through this cycle once, then I'm going to get new puppies, because these 10 juveniles are each going to produce 2 puppies, so that's 20. And these 15 adults are each going to produce 6 new puppies rather, so that's 90. I'm going to get new juveniles because these puppies, 60% of them anyway, are going to grow up. So 60% of 20, that's going to give me 12. And I'm going to get my new adults because 80% of those 10 juveniles will survive, or 8. And 70% of my existing adults will be alive for 1 more year. And that's the one where I said, okay, I just made this up. The number isn't pretty. We don't want to think about partial animals, but 70% of 15 is 10.5. And then essentially, those would become my populations to run this whole cycle again. Yesterday, we said that each of our puppies, they're not reproductively viable. They can't give birth, but our juveniles can. They're just worse parents. So on average, 2 puppies per juvenile are going to survive. Our adults, they're better parents. So on average, we said 6 puppies per adult were going to survive. I just made that up. I'm not a biologist. We also said that 60% of our puppies would survive to become juveniles. 80% would survive of our juveniles survive to become adults, and 70% of our adults survive to live another year. We also kind of summarized that in a chart that looked like this, where our puppies moved to be our juveniles, who moved to be our adults. Our adults have 6 puppies, our juveniles have 2 puppies. Well, we can take this same system and actually think about writing it in terms of a matrix. So I need just a little bit more space here at the bottom, so I'm going to tuck this in a little bit tighter and say that was a 6. So I don't know that I've got time to do all of them, but let's see how far we can get. So my puppies next year, so I'm going to give that a subscript of t+1. My puppies are going to come from the number of juveniles I have right now times 2, because each of those juveniles on average is having 2 puppies per cycle. So my puppies next year are going to come from twice the number of juveniles I have this year. Plus, we're also going to get puppies from the adults. So each adult on average, we're going to get 6 puppies. I know it's a lot of puppies, totally unrealistic. So 6 puppies per adult that I have right now. The juveniles that I'm going to have next year are coming from the puppies that are growing up. So we said 60% of our puppies survive to become juveniles, which means to get how many juveniles I have next year, we're going to take 60% or 0.6 times the number of puppies I have right now. And last, to get the number of adults, some of my juveniles are going to grow up to become adults. We said there was an 80% survival rate there. So I'd have 0.8 times the number of juveniles I have right now, plus some of our adults survive another year. So 70% of our adults survive to come back and still be adults. So 0.7 times my adults right now. Now that we've got this system of equations, we can write this system of equations in its matrix form. And I'm going to do that by having my matrix of coefficients times the vector of our variables. So puppies at time t, juveniles at time t, adults at time t. And the result is going to give me my puppies next year, my juveniles next year, and my adults next year. And I know I'm kind of squeezing this in, but in terms of that matrix of coefficients, over here, I don't have a puppies term, which means secretly in that top row, there's a 0 on my P sub t. So this would look like 0, 2, 6. In my next row, I only have that P sub t term. I don't have any juveniles or adults. So this would look like 0.600. And for my adults, puppies can't skip straight to being adults, even though my 16-year-old son, who's kind of a juvenile, would like to have gone straight from puppy to adult. Doesn't work that way. Got to pay your dues. Got to go through that juvenile phase first. So our adults don't have a puppies term. There's a 0, secretly a 0 P sub t there. So I'd have 0, 0.8, 0.7. So this is where we're going in the next section, is to talk about population dynamics kind of evolving over time and how we can represent that either with diagrams like this or with a system of difference equations. And finally, moving it into a matrix form, because there's some really cool things that we can do once we're working with it as a matrix equation.